Next, we show how to perform memory and processor analyses on an AADL model. We show it in both formats, the original plugin format and the new workflow format. The AADL model we'll be using is an elaboration of our familiar resource budget AADL model, which consists, you might recollect, of a digital control system, which is made up of a hardware platform, and a digital control application, which in turn is made up of two processes, an I/O process and an actuator control process, whereas the platform is made up of processors and a main memory. It's the main memory here that we will be focusing our attention on, as well as two sensors and an actuator, and these are combined and integrated into a sensor control system. If we select the sensor control system on this elaborated AADL model and generate an instance from the system implementation ses.dualtier2, we can now run one of the memory analysis plugins. Analyze resource budgets not bound works in this way. It pools the providers of RAM and ROM capacity separately, once for RAM, secondly for ROM, and compares that to the total RAM demand and ROM demand, and sees if there's enough capacity to meet the demand. The RAM demand is specified for a software component by making use of the SEI RAM budget or ROM budget property. And the capacity likewise is assigned through the RAM and ROM capacity property assignments, as we saw earlier. So if we run this analysis, the first of the two analyses, we will get a report that looks like this. Each of these reports is in multiple segments, one dealing with the processor analysis, which we will deal with later. But our focus is really on this part of the report. These are summaries of the RAM analysis first and the ROM analysis second. And what does this report say? It says that our SES Dual Tier 2 system instance has inadequate RAM capacity, 1 gigabyte, to meet a RAM budget of 1.39 gigabytes. But the ROM summary report indicates we are fine. We can look down further in the report and see what's going on, as there are detailed breakouts showing the various contributors to the overall RAM budget as well as ROM budget. So going down now to look at this detail, we see the sensors, two sensors and actuator, contribute to the RAM demand, and the two processes likewise contribute to the RAM demand. And if we add these, 610 and 780, we get 1.39 gigabytes RAM demand. Likewise, if we do the same for ROM, pooling across the entire SES Dual Tier 2 system implementation, we have 0 ROM demand from the sensors or actuator, but we do have ROM demand from the two processes, the I/O process and the actuator control process, totaling 1.22 gigabytes, which is within actually our ROM capacity of 2 gigabytes. In addition to pooling ROM capacity and comparing that against total pooled ROM budget across the system, and likewise for RAM, the plugin does a more nuanced analysis, a compositional analysis, to be more precise, of the budget assignments at different levels. In order to see this, it helps to look at this detailed budget report a little more carefully. So at the top level, we have the sensor control system, the SCS. It's decomposed into the two sensors, actuator, and digital control system. The digital control system, in turn, consists of a digital control application as a subcomponent. In addition, there's a hardware platform, but it has no software subcomponents, so there is no interest in pursuing that here, and it doesn't appear in the report. But if we focus on that digital control application, or dcs.app, we see that it in turn is decomposed into two processes that we've been speaking of, the I/O process and the actuator control process. During design, as budgets are assigned top-down, it is possible that inconsistencies will arise as negotiations occur between the party responsible for an upper level component, such as the digital control application, and parties responsible for the subcomponents, in this case the two processes, the IOP process and the actuator control process. And indeed, such an inconsistency has happened here, as we can see from the total ROM budget allocation under the digital control application, that is 720 plus 500 megabytes equals 1.22 gigabytes, when compared with the budget for ROM allocated for the digital control application as a whole. And that is what this error message reports. And so this is an additional analysis that the plugin provides. Let us now contrast what we have just seen with what we get in the workflow analysis view. We can bring that up, as you see here. Notice that there is a box for selecting an instance model, a box for looking at contributors to memory capacity, another box for looking at contributors to memory demand, and two reports that we can run. We've already seen the unbound memory analysis, and we will shortly see the bound memory analysis. First, we select an instance. There's only one at this point. And then we can view the contributors to memory capacity. And there's just one of those, namely the main memory, which contributes RAM and ROM capacity. Likewise, we can view the various contributors to RAM and ROM budget, and we can see them all at a glance, which was not possible, or at least not so easily possible, with the plug-in reports. You can see here all the contributors to memory demand. The two sensors, the actuator, the two processes, which are part of the digital control application, which has its own RAM and ROM budget assignments. Then we can generate the reports, and we will do so. Let's see what reports we generated. Only one. The same report that we obtained by invoking this plugin here. There should be a report for this plugin, but we see no report. Why? Because this plugin does an analysis not across the system, but on a memory component by memory component basis. In the case of our Memory Test 1 AADL model, we never bound any of the software components to the main memory, or any memory. In order to see what this second report would have contained or should contain, we need to add an additional property assignment. That property assignment will be associated with SCS Dual Tier 2. And that property assignment is an actual memory binding property assignment that maps a physical memory, in this case the main memory on the platform, to our 5 software components, the device drivers for sensor 1, 2, and the actuator, and the 2 processes that are part of the digital control application, IOP and APP. So let's see what that looks like in our workflow. First, we need to regenerate a model instance for SES Dual Tier 2. Then we open the memory workflow. Select the model instance we are interested in. There were no changes to memory capacity or memory demand. We want to directly generate the bound memory analysis report. So we click on here. Opening the reports we've just generated under bound resource budgets, we find a by memory device memory analysis. There is only one memory device, the main memory. There's a separate detailed report for RAM and for ROM. The ROM's on top. You can see that because of the 2 gigabytes capacity and the 1 gigabyte RAM capacity, and also because we bound all 5 components, software components, to the main memory, but only 2 of them had a ROM memory budget, which appears here, while all 5 had a RAM memory budget. And so in this way, we have a more detailed view, granular view possible into the use of memory in the SES Dual Tier 2 system. However, we still have a problem to solve. We have inadequate RAM capacity in our system. We can solve that by adding additional memory. We can enhance our AADL model as seen in this AADL file here by adding auxiliary memory. So an auxiliary memory might be similar to the main memory, but just providing RAM capacity. It's maybe less expensive, maybe slightly more reliable, and we only need RAM capacity, so we will include that. That is included then in the platform. You see it right here, and then also in this other platform implementation, which is actually the one we want, Platform Dual, down in the digital control system, and then in the sensor control system, Dual Tier 2. We thus have 2 memories that we can bind our software to. And we can split then the software. Since the 2 processes have ROM needs additionally, we will keep them mapped to the main memory. But the 2 sensors and actuator have no ROM budget or need, and we will map them to the auxiliary memory that we have just added. First, we regenerate our instance model for SES Dual Tier 2. Then we go back into the memory analysis workflow view. Select the appropriate instance and regenerate our reports. And if all has gone well, we should be able to see that we have adequate memory capacity now. So we will first check the unbound report. Just extending the columns here a little bit. Now skipping past the processor report, we come first to the RAM report. which is in two sections. The summary for RAM capacity. We see the additional auxiliary memory there included in the RAM capacity report. And we have the same detailed RAM budget report, but the total, 1.39, is well met by the RAM capacity. And of course, there's been no change to the ROM capacity report and budget reports. Let's suppose that instead of inserting an additional memory into our system, there's an alternate to the main memory that has the same amount of ROM but twice as much RAM capacity. I'd like to show you that the workflow view provides a means for making that change in the specification and rerunning the analyses directly without having to go either into the AADL model or the model instance. So we have selected the same memory 2 AADL model that we saw earlier. That's the one with the single physical memory. But now we're going to edit the amount of RAM capacity that it makes available. I'm going to double that, regenerate the reports, open them. I'll just actually open the unbound version of the report, skipping past the processor analysis. And what we see is our single memory having twice the amount of RAM as before, and that we can indeed meet the total RAM budget. The ROM capacity and budget are unchanged. So what we have just demonstrated is a way to make a small change directly in the workflow without having to get into the AADL model. So in summary, what have we just seen? We have seen that we can analyze the way memory is utilized in an AADL model. We've seen it both with the original memory analysis plugins and also the workflow view. The workflow view provides a degree of simplicity and control that is lacking from the direct generation of the reports